Today we're going to learn about how to solve two-step equations that involve a fraction as a coefficient of x. A coefficient of x is the number that's in front of x telling us how many there are. Usually you'll see something like 3x. That's the same as 3 times x, and we divide to get rid of it. 3x means, hey, there's 3 x's here. X times x times x. It's a shorter way of writing 3 x's. In this case, we're going to be talking about what happens when we have a fractional coefficient, a fraction in front instead of a whole number. To get rid of or cancel out a fraction, we multiply by the reciprocal. R-E-C-I-P-R-I-C-A-L. Reciprocal is the opposite or the inverse of a fraction. Basically, you take it and you flip it over. So for example, the reciprocal of 2/5 would be multiplying times 5/2. We reverse the numerator and denominator. The setup is going to be the same. We draw a line down the middle and then we circle our variable, which in this case is on the left. We have 2/3 x equals 10. To cancel out that fraction, we multiply by the reciprocal, or the opposite. The flip, or opposite, of 2/3 is 3/2. Just switch the bottom and top numbers. Now whatever we do to the top, or to the left, we have to also do on the right. So, as you may have noticed during the warm-up, when you multiply 3 times 2, you get 6, and 2 times 3, you get 6. 6 over 6 ends up being just 1, or 1x. 10 times 3/2, to multiply that together, it's usually easier to make the 10 into a fraction. You can change any whole number into a fraction by putting it over 1. 10 divided by 1 is still 10, so we haven't changed the value. Then we multiply across. 3 times 10 is 30, and 2 times 1 is 2. So we have 1x is now equal to 30 divided by 2. Now we don't usually write 1 in front of the x because it's assumed if we're writing an x there, there's at least one of them. So what we normally write instead is just x equals, and then we can simplify our fraction. 30 divided by 2 is 15. So x equals 15. Let's try it with a negative. Now we have negative 6/5 times k. So our variable is k, and our coefficient is negative 6/5. Now when the negative is out front like this, you can put it in either the top or the bottom, one or the other. Just for consistency's sake, I usually write it in the top. So instead of writing it as negative out to the side 6/5, I usually just stick it in the top and say negative 6 over 5. So I would suggest that that's how you do it so you don't forget that negative because we need it there to cancel it out. So negative 6/5, and then I'm just going to change this into a multiplication sign and multiply by the opposite, which would be 5 over negative 6. Make sure that we do that to both sides. And to help us out, we change our 12 into a fraction by putting it over 1. This will cancel out and make negative 30 over negative 30, which is positive 1. And we bring down our k. On the other side, 12 times 5 is 60, and 1 times negative 6 is negative 6. This simplifies. 60 divided by negative 6 is negative 10. Feel free to use Desmos if you're not sure what it simplifies to. Why don't you try and go ahead and do the next two by yourself and check in with me in a moment. All right, let's check your work. So you should have flipped this over to be 9/4 on both sides. Canceled this out and bring down the w. Then negative 8 times 9 is negative 72, and 1 times 4 is 4. Negative 72 divided by 4 is negative 18. Here, the reciprocal of negative 1/2 is negative 2 over 1. Make sure to keep that negative sign in with a 1 so you don't forget it. That will cancel out and make 1m. Bring down our m. And negative 9 times 2 is negative 18. And negative 1 times 1 is negative 1. Negative divided by a negative is positive 18. Let's move on to remind ourselves about a couple of our normal problems here. Now, in this case, these are the problems that you're a little more familiar with. We look at our variable here and draw our line. We do have a constant, has a plus with it, so we would subtract 9 first. We always get rid of any addition or subtraction initially. Cancel that out by subtracting 9 on both sides, and we bring down the plus x divided by 4. Now, we don't need the plus because it's assumed to be positive unless we say otherwise. Now, this is the way we're used to seeing it, where x is being divided by a number. Then we have 14 on the other side. You can multiply by 4 over 1, but what we normally do in this case, if it's not a coefficient in front of x, if x is being divided, is just multiply on both sides. Okay, so this is the problem that we normally see where x is being divided, without it actually being a fractional coefficient. Then we cancel this out, and we get x is equal to 4 times 4 is 6, carry the 1, 4, 5, negative 52. Or excuse me, negative 56. Okay, why don't you go ahead and try the next problem and pause it and we will return. So you should have gotten x is equal to negative 15. On this particular case, when you identified your variable, you may have noticed that it was on the right. So that's the side we're working on. It doesn't matter whether it's on the left or the right. We box our constant of plus 8 and then cancel it out with the inverse of minus 8 on both sides. Once we bring down 3 and the x divided by negative 5, we multiply by negative 5 on both sides to cancel out the division, leaving us with x is equal to negative 15. Now let's look at a problem that looks like it should be simple, but can be a little bit strange if you haven't encountered it before. So here we've got our x. We can circle it, draw our line down the middle, and there's a constant, there's a 4 that's separated by a minus sign. That minus belongs to the x though. Since the 4 doesn't have a symbol in front, we know that it's a plus. We cancel that out easily enough with the inverse of subtraction, and then bring down what's left, which is our minus sign and our x. On this side, 4. So here's the issue. What do we do now that we have the negative sign? How do we get rid of it? Well, one thing to keep in mind is that even though we normally don't write it, this does have a coefficient of 1. It's negative 1x times, or negative 1 times x. So an easy way to get rid of our negative is to divide by negative 1. It doesn't change the value, but a negative divided by a negative makes it a positive value. We do the same on the other side, and it'll change the 4 from positive 4 to negative 4. So that creates a positive x and a negative 4. You'll notice we just switched the signs. Let's take a look and try it again. Again, here's our variable, and it has a negative in front, and that's it. Our constant is minus 3. We can add 3 to both sides to get rid of that, leaving us with just the minus x and a negative 3. And we know that this is the same thing as negative 1x. So let's consider just dividing by negative 1. A negative divided by a negative makes this a positive 1x, or just positive x. We've gotten rid of that negative sign. But we have to divide by negative 1 on this side too. Negative divided by a negative becomes a positive 3. So if you change the sign on one side, you change the sign on both sides. And this can be accomplished by dividing by a negative. The last type of problem that we're going to look at is when you have grouping. You'll notice This one's a little different because not only is x being divided, but the x and the operation of subtracting 4 is being divided. So you can think of this when you see an operation in the numerator or in the top of the fraction as being grouped. So we can't take care of this top part of the numerator before we get rid of the denomination or the denominator of dividing by 8. When you see one big fraction like this, or an operation in the top of a fraction, you need to get rid of the division first. Even though normally we would get rid of the constant first, this is the one time you're going to get rid of division first. Because this is grouped, we can't take it apart until we get rid of the bottom. So multiplying by 8 gets rid of the fraction or the division of 8, leaving us with just the top of x minus 4 and 16. Now that it's all by itself, we can take care of this constant and get rid of the minus 4 by adding 4 to both sides, leaving us with x is equal to 20. Let's try one more of those together, and then you can try one by yourself. So when I look at this problem, what I see is not only d being divided, but I see a negative or an operation in the top. That means that it is grouping, and I know I need to get rid of the division first. So we multiply by 3 on both sides to cancel out the bottom first, leaving us with d minus 2 is equal to 21. Then we add 2 to both sides, leaving us with d is equal to 22. Go ahead and try the last one by yourselves. So again, we have a problem where x and another number with an operation is in the top being divided by a value. So we know that that's grouped, and we need to get rid of the negative 8, or divided by negative 8 first, by multiplying by negative 8 on both sides. Once we've canceled that out, we're left with just the top, the numerator of x plus 5, which we can cancel out easily by doing the inverse of subtracting 5 on both sides, for x is equal to 3. Good luck as you continue to work with two-step equations and fractions.